So last lesson was about sequences and series that don't necessarily have a pattern to them. The next two lessons are about particular patterns to them. Okay. The first day is about arithmetic sequences and series. And the next day will be about geometric sequences and series. Thank you. Now, everybody should have a formula sheet. The Algebra 2 SOL formula sheet. And you notice on the bottom here, it's all about arithmetic and geometric sequences and series. So they give you formulas for everything you need to do for this stuff. So today we're going to be doing all the formulas under arithmetic. We'll see what they do for us and you know how to do them in practice. So the definition of an arithmetic sequence is a sequence in which the difference of consecutive terms is constant. Right? That difference is called the common difference. And we use lowercase letter d to represent common difference. Right? What does consecutive mean? What does the word consecutive mean? Yeah, in a row, right? One after the other, consecutive. Difference means subtraction. So just to be clear, when it says common difference, it means you subtract the second term by the first, not the first by the second. So the difference of consecutive terms is constant. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2, right? The D, the common difference, is 2. In this one, 7 minus 9, it's actually, the terms are getting smaller, right? So the common difference is negative. So the terms are getting bigger, it means you're adding positive D. Terms are getting smaller, then you must have a negative D. You good? Sarah? You good? Okay. So we ought to be able to look at a sequence of numbers and tell whether or not it's arithmetic. And if it is, state the common difference. Okay. One of those is arithmetic. Which one is it? You know, all you can do is just start subtracting, right? 1 minus negative 4 is 5. 6 minus 1 is 5. 11 minus 6 is 5. 16 minus 11 is 5. So the common difference, there is a common difference, therefore it's arithmetic, right? So this is arithmetic. How about the second one? Second term minus the first term, 2. Third term minus the second term, 4. Okay. Not common difference. So it's not arithmetic. Next. So is that one, you try that one, is that one arithmetic? And if it is, state the common difference. That ought to take you 3.4 seconds. Okay. What do you say? Arithmetic or not? Okay. 14 minus 17 is negative 3. Right? Terms are getting smaller, so it needs to be negative. So that is the D, so this is arithmetic. Okay. So we have a formula for the nth term of an arithmetic sequence. That's it. If you look on the formula sheets, under arithmetic, it's the first formula. So look at all the terms in this. We already know AN means the nth term of the sequence, right? It's going to determine the nth term of the sequence for us. What is A1? The first term of the sequence, right? And the N is matching the N, right? It's the ordinal number. It's the second, third, fourth, whichever term you're looking for. And D is common difference that we just introduced. All right, those are all the parts to it. Now, what we have to fill in here is for A1 and D. The AN and N, those are variables, kind of like f of x and x. I mean, your equation has those in it. They don't go away. But we have to fill in for the constants, right? So A1 and D are constants we have to figure out and plug in. Okay. Okay, so let's find formulas. For the first, I mean, before you can find the formula, you got to make sure it's the right kind of sequence. Does the first sequence look like it's arithmetic? It does. It looks like we keep adding 5 to get the next term, so definitely we're going to say this is arithmetic. It looks like D is 5. So if I want to use the formula from the last page, right, I'm going to rewrite it first. AN equals A1 plus N minus 1 times D. Okay, now I need to fill in for A1 and D. Okay, so what is A1? Right, A1 is here. And we've already identified the D. So plug in AN equals 4 plus N minus 1 times 5. AN equals, we should simplify that, 4 plus 5N minus 5. So AN equals 5N minus 1. Right, that's the formula. Again, it's like f of x and x. Those are variables. They're going to be in the formula because now we can use this to generate any term in the sequence. Now, what we should do before we go forward is just let's make sure that it works for the terms that we've got. You know, if you made a mistake, it won't work. You need to go back and check your math. But if I plug in n equals 1, 5 times 1 minus 1 is 4. 5 times 2 minus 1 is 9. So it looks like it's working, getting us the right terms. Now, this should, you know, speaking of f of x and things like that, this should look linear to you, right? It's kind of like y equals mx plus b. You know, arithmetic sequences have formulas that look like mx plus b. Because, every time you increase n by 1, you end up adding one more of whatever the number is in front of it. Right? That's how it works. Right? This can be the starting point, and then you keep adding 5 and adding 5 and adding 5. So it should look linear. How about the second one? What is the d on this one? Yeah, this d equals -8. So we're going to say an equals, the first term is 60. The d is -8. And then we simplify. An equals 60 minus 8n plus 8. An equals -8n plus 68. Now you could write 68 minus 8n too, it doesn't matter. I'm kind of consciously writing it like it's a mx plus b kind of thing, but you don't have to. Again, you could check it, make sure that it works, right? N equals 1 should give me 60. -8 times 1 plus 68, 60. -8 times 2 is -16 plus 68, 52. Okay, so just check it out. Good. Try this. I think you got one now. So try to come up with the formula for that one. So let's see. The first term is 17. The d is -4. Right? You got at least of that part right. So an equals 17 plus n minus 1 times -4. So an equals 17 minus 4n plus 4. And you could check it out, right? N equals 1, you should get 17. -4 times 1 is -4, plus 21 is 17. The thing to keep a lot of times these problems say, find the formula, and then it says, and then find A30, something like that, right? So make sure that you don't just like go to this thing right here before you've ever simplified it and plug in 30, because you'll never have a formula. The formula is something like that, which has got an n in it that you can use to find any term in the sequence. If all you did is plug in the very first step the A1 and the D, and you put the 30, you never made a formula. So make sure you write a formula, then find any particular term in the sequence. Okay. I think I skipped one there. What? Something seems goofy here. No. Okay. So see what you could do with this one. This is not giving you the kind of information we had already. They're telling you two terms in the sequence and saying find the formula for the nth term. So you're going to have to figure out how can I find D first, and then how can I find the A1 so I can put it in the formula. I mean, think about it. How are we going to find D? We have the 7th term and the 16th term. How are we going to find D? Okay, Nate? Yeah, I mean, how many times are you going to add D to go from the 7th term to the 16th term? 9 times, okay? That's what you need to do to find the D, okay? They've given you the values for A7 and A16, so use those and use the fact that it's going to take 9 times you're adding the D. See if you can figure it out. So, you know it takes, to go from the 7th term to the 16th term, you have to add the common difference 9 times. So that's an equation. We know this number and this number, they were given. So you plug them in, and the only thing left to find is D. Right? Then over here, right, to go from the first term, which we need to know, to the 7th term, we got to add the common difference 6 times, right? 7 minus 1 is 6. So we know that because we just calculated it, and we already knew the A7, so you can solve for the A1. So now you know A1 and you know D, so you find the formula. Now you may, like, let's say you get to this point and you found D is 5. You might have just said, okay, well, if I'm at A7 is 26, well, let me just subtract 5 6 times. Okay, that works too. Okay. Oh, that's wrong. Okay. So now we also have a formula to find the sum of an arithmetic sequence. Capital S stands for sum. Right? On your formula sheet, it's under the column which says arithmetic, it's the 3rd one down. Now, the fact that it has this subscript of n means you're adding up n terms. You're adding up a finite number of terms. There's no way to add up an infinite number of terms for an arithmetic sequence or series. So S sub n means this is the sum of a finite arithmetic series or sequence, whichever you want to say. So the n equals the number of terms. The A1, what does that represent? First term. And AN, if you're finding the sum of 20 terms, that's S20, and that means it's A20. It means it's the last term, right? So last term. All right, so evaluate the arithmetic series. Now, we saw last class that, honestly, there's a summation notation, a function inside the calculator to do this. But right away, I'm going to say I'm going to do it using the formula instead of doing that. Right? So let's see. My formula is this: Sn equals n over 2 times A1 plus An. Okay. Looking at this summation, how many terms are there going to be? Starts at 1, ends at 20. Looks like we've got n equals 20. Right? How will we find the first term? Right. For the first term, you plug in the lower limit, right? That'll be A1. So in this case, A1 will be 3 times 1 plus 5, which is 8. Okay, how am I going to find the last term? Plug in the upper limit, right? Right there, AN. So in this case, I'll call it A20 is 3 times 20 plus 5, which is 65. So now I have everything I need to plug in that formula. Right? S20 equals 20 divided by 2 times 8 plus 65. S20 equals 10 times 73. S20 equals 730. So because you have the calculator, that has the summation notation, this is the kind of problem that I might not ask you to find the sum. I might say, how many terms are there? What's the first term? What's the last term? And then not ask for the sum. Okay. Good. You good, David? You okay? Okay. Now, this sequence here, right? I've only got 3 terms there. Does it look like it might be arithmetic? Yeah, it does. It's the same one as the summation on the previous slide. It's just being presented in a different way, right? When you get a series that looks like this, you don't know the last term, right? I can see the first term, but I can't see the last term. I know that the n is 20, right? Because it says add up 20 terms in this sequence. So I don't have all the information that I need to do this. Before I can go any farther, I need to know what the 20th term is. Okay, and if I didn't have the last slide, because I already know what it is, it's 65. But how would I find the last term if I just had this to work off of? I would use this formula, right? I would use the AN equals A1 plus N minus 1 times D, right? So I can find the last term, but I'd have to do this in 2 steps, right? First step, find the last term. A20 equals 8 plus 20 minus 1 times 3, and A20 equals 65. We already know that. Yeah. And then I can use this formula, Sn equals n over 2, A1 plus An. Sorry. And then I can plug in all those same things. We're going to get the same answer if we do it because it's the same problem as the last slide. But so if you have something like this which is not presented with the last term, you got to find the last term so you can use the formula. Okay. Or you do this. Make sure everybody's ready. Okay. Like this did. Okay. Oops. You can actually combine the 2 formulas into one, right? I could take the formula for AN and replace the AN in the SN formula, right? Then it looks like this. Then I can combine the 2 A1s into 2 A1, and I get a formula that doesn't require the last term anymore. That's the last formula on the sheet right here. So this is the formula you use when you don't know the last term, because now all I need to plug in for is the number of terms, the first term, and the common difference. And I can tell that just by looking at the series, right? If I know the last term, then I use the first SN formula, right? So that's the one for if you know the last term. The last one is when you don't know the last term. It kind of just incorporates the finding of that term into the formula. So find the sum of the 15 terms in that series. Right? Just use the formula. Plug in everything. Plug and chug. Good with that? Okay, a recursive formula, right? A recursive formula is actually for arithmetic sequence, right? There was 4 formulas in that column. The first formula that we were using for AN is called the explicit formula. If you have an explicit formula, you plug in N, you find out the term. That's all you need. A recursive formula tells you the value of A sub n based on the value of the term before it, right? So we're using subscripts now, A sub n for the nth term, A sub n minus 1. So like if that was A2, right, n is 2, then this term would be A1. It's telling you just relative position. AN is the term right after AN minus 1. What do you think is the term right after AN? AN plus 1, right? So these subscripts are just telling you, relative positions of the terms in the sequence. So any term in an arithmetic sequence is the term before it plus the common difference. Makes sense, right? That's what we've been doing. I mean, it's really pretty basic if you ask me, but sometimes recursive formulas can be more complicated and they tend to cause a lot of confusion. We don't really deal with them much, but they're specifically mentioned in the SOLs that we're supposed to know the recursive formulas for the nth term for arithmetic and geometric. And both columns, it's the second one, right? So we're going to do a bare minimum of this. Okay, that's good. So, for example, this is a recursive formula for an arithmetic sequence. It says that the nth term is the n minus 1 term plus 4. So what does the plus 4 represent? Just a common difference, right? That's all it is. Now, before you can make any terms out of that, you got to at least know one term first, right? And that you do because it says A1 is 1. So now you can find A2. Using the recursive formula, you find A2, right? A2 will be A1 plus 4. But A1 is 1, so that's 1 plus 4, 5. What will A3 be? A2 plus 4, right? Which will be 5 plus 4, which is 9. So in the end, what are you going to do? You just keep adding 4 to find the next term. It's what you would do just instinctively. This is kind of just putting some formulas behind it. A4 equals A3 plus the common difference. 9 plus 4. A5 equals A4 plus 4. 13 plus 4. And A6 equals A5 plus 4. And do those look like they are arithmetic? Looks like it's plus 4 to get everything to the next one. Okay. Okay. So here's one for you to try. A1 is 3, and AN is AN minus 1 minus 7. You don't have to write out everything that I wrote in the last slide, but what are the first 6 terms of that sequence? You know A1, what are the next 5? Well, looking at the recursive formula, what is D? It's negative 7, right? So find the first 6 terms of that sequence. Okay. Good. Okay, we're almost done. So write the recursive formula for that sequence. Is it arithmetic before we get started? Yeah, it looks like it is. So what's the formula for it? AN equals AN minus 1 plus 10, the common difference. So let's do one more. Do the same thing on that one. Write the recursive formula. AN equals, what goes after the n minus 1? Minus 6, right? D is negative 6. So recursive formulas can be more than just like, add something to the term before. We're going to find for geometry, it's multiply the term before by something. There's a sequence which I have a feeling you've heard about because in the last class they seem to have heard about it, but it's called Fibonacci sequence. Where did you hear about that? Where? In art? Okay, well, a Fibonacci sequence is like this. AN equals AN minus 2 plus AN minus 1. So any term in the sequence is equal to the sum of the 2 terms before it. And so in order to get started, like we needed 1 number to start, and then you could keep going from there, you need 2 numbers to start. So we're going to start with A1 is 1, and A2 is 1. then what would A3 be? A3 would be the sum of A1 and A2, so that is 2. A4 would be the sum of A2 and A3, that is 3, right? A5 is 5, right? And then it'll be 8 and 13 and 21, and these are called Fibonacci numbers. Fibonacci was a famous Italian guy. So let me pause this right here. Okay, there's the homework. Okay, now you're done.